Now we'll study about the steady state analysis of circuits with the resistances and capacitors. So when we talk about RC circuits, we have already discussed that in a steady state, we have discussed that a steady state is a situation in which we can say it is the full charged state of capacitor. When capacitor are fully charged, current through capacitor becomes zero. So whenever we talk about the full charged state of a capacitor, current through the capacitor becomes zero, that we already studied. So based on this, we can write in any circuit with capacitors, always current in all branches in which capacitors are present will be zero in a steady state. Like if we just analyze a simple question, a simple problem is given in which say 3 capacitors are connected with 2 resistances along with a battery. Say here the battery is of 30 volt and say the resistances are 6 ohm, 4 ohm, and the capacitors are also given as 4 microfarad, 2 microfarad and 6 microfarad. And in this situation, say we are required to find the charge on the 6 microfarad capacitor in steady state. Say the example is given in which we are asked to find charge on 6 microfarad capacitor in a steady state. So steady state will be the situation in which all the capacitors will be fully charged as per the potential difference available across each capacitor. And finally, the current through these 3 branches wherever capacitors are present will be zero. So we can say in a steady state only current will flow in this loop, and the value of current we can write as 30 divided by here 6 and 4 can be taken in series combination, that is 10 ohms. So the current will be 3 ampere. Here you can see I have ignored the 6 microfarad branch of capacitor because in a steady state no current will pass through this branch. So whole of the current of 6 ohm will pass through 4 ohm. So here we can consider these two in series combination. So if we have got the value of current as 3 ampere, we can find out the charge by using the nodal analysis method. Here for this 30 volt battery, we can consider potential here to be 0 and here to be 30. Then in this situation, we calculate the potential at this point. It will be 6I less than 30 volt. And here I is 3 ampere. 6I will be 18. So it will be 18 less than 30. So the potential at this point will be 12 volt. Now we consider potential at this node to be X. We can write down the nodal equation. In solution, we just start with the nodal equation for junction with potential X. If we calculate, we need to sum the charges of all the plates connected to this node should be equal to 0. So this can be written as twice of X minus 0 plus 6 multiplied by X minus 12 plus this will be 4 multiplied by X minus 30, and this equals to 0. Now in this situation we further simplify here. This 2 gets cancelled out. This will be 3. And on further simplification we are getting 3 plus 2, 5 plus 1. 6x is equal to, if we just calculate the numerical values and take it on the other side of equality, this will be 36 plus 60, that will be 96. So the value of x you can see here we are getting 96 by 6, that will be 16 volt. So if we know the potential at this node, that is x, which is 16 volt, we can directly calculate the value of charge on the 6 microfarad capacitor, that can be written as 6 multiplied by the potential difference. So if X is 16, the potential difference across this 6 microfarad, you can see here it will be 4 volt. So we can write it to be 6 multiplied by 4, that is 24 microcoulomb. That will be the answer to this problem.